Hello and welcome back to Cracking the Cryptic. And the puzzle we'll be doing today is called Toothbrushes by Cranguna. Now you may be wondering why no puzzles for the Jubilee. It's a big thing in Britain, right? And it is. It's been going on for 4 days now. We didn't get sent one is the simple answer. The more complicated answer is that I've tried to create one. And in the end, I just couldn't convince myself that it was fair. I'm pretty sure it's unique in that it solves completely, but it's got some rough steps in it, perhaps. I don't know. I'm not entirely sure. What I've done now is put it up on Patreon. We will leave it up for 2 or 3 days, and then we'll put up a video of me making the puzzle, which might be interesting. People do often ask for explanations of how people make puzzles, and we've we've featured a number of really excellent set of videos, but we do make some puzzles ourselves, and you might be interested to see how I went about it and what was going on. So I don't know, it's something that may be of interest, and as I say, the puzzle itself is up on Patreon, not ruling out that people will have said by now that it is either unsolvable or wrong or something. I don't think that's likely, but you never know. And we'll be inviting a bit of comment on that there, and then putting up a video on how it was created. So anyway, that's on Patreon, along with the PBN Institute puzzle packs, which are proving so popular as the June monthly Patreon reward. Thank you to anybody who is with us on Patreon. We are very grateful. Thank you to people who've done super thanks comments, which we weren't really aware of until very recently on the channel. Apparently you can give a bit of money as you make your comment, and it gets drawn to our attention. So well done if you've done that. Anyway, there is also our apps if you really want to spend your money on Cracking the Cryptic, and merchandise too, and Sven's Sudoku Pad, all on the links under the video, along with Patreon and Discord. Check them all out if you're interested. But the first link is to this puzzle by Cranguna, who we featured on the channel before. And this puzzle's called Toothbrushes, I think because of the shapes of some of the grids. Yes, there's the toothbrush, and that's presumably the toothpaste on top. There are 2 of those at the top and 2 reversed ones at the bottom. Excellent. So this is an irregular Sudoku, so we can't say normal Sudoku rules apply. 1 to 9 appears in every row, column, and marked region. So that will be a set of the numbers 1 to 9. But we don't have the 3 by 3 boxes, obviously. And we have arrows. So normal arrow rules apply, which are that digits on an arrow add up to the number in the circle. So those 3 add up to that. That's what we get. Do give it a try. No idea how this plays, but I'm going to find out now. Let's get cracking. And what do we know? What can we see about this grid? I think these toothbrush shapes are I'm immediately looking for sort of geometry things, like what's going on in the grid. It's quite interesting, actually, because the normal law of leftovers rules aren't that useful. You could draw a line under row 4, but that's actually already drawn in the grid. This row 5 is a region of its own. And the vertical lines, most of them come between columns 3 and 4, columns 6 and 7, but there's a lot of cells sticking out and a lot of cells sticking in. Okay, I think the toothbrushes may be the way in, so I don't know. Okay, those 3 cells, yeah, the simple question is, where do they appear in row 2? They can't be in the same region. So those 3 cells must be exactly the same 3 cells as are here. The same's going to be true here. We've got those 3 cells in row 4, can't be there. And I think we can replicate this all the way down. So I've got kind of now purple toothpaste, blue toothpaste, green toothpaste, and yellow toothpaste. Right. Yes, look. These 5 cells. Oh, that's very interesting. Okay, a number of things I will point out here. One is that these circles are in the same column, so they can't be the same. So the most they could add up to is 17. Now, what is the least that purple and blue can add up to? Well, don't look over here. Look over here. And it gets more interesting. Over here, those 5, they're all in the same region. They all have to be different. They've got to add up to at least 15. But remember, the totals of blue and purple can't be more than 17. So this has to be a 1 or a 2, which will also appear here because these now either add up to 15 or 16. They include 1, 2, 3 and 4 and either 5 or 6. And we've got the symmetrical position down here. Yeah, I mean, it's exactly the same. Those two are in the same column, so the most they can add up to is 17. The least these can add up to is 15. So this is a 1 or a 2. Oh, this gets better. Look at this crazy cell. The grey cell is... grey's a poor colour. Let's go light grey. That's really significant. Yes. If this was 1, 2, 3, 4, 5 in these yellow and green cells, that would have to be a 6. And how could this be 1, 2, 3 or 5 then? The arrow wouldn't work. And I mean, obviously that could be higher than 6, but that just makes the problem even worse. So these are not 1, 2, 3, 4, 5. These are 1, 2, 3, 4, 6. This is a 1. This whole set of green and yellow adds up to 17. There they are again. So those circles are 9 and 8. And what can we put here that is less than any of the numbers 1, 2, 3, 4, 6? Obviously a 5. And this is the 6, therefore, and we get a 1 here. And we are in business now. That's a 2, 3, 4 triple. So in this region, that's a 7, 8, 9 triple. Ah, now we know there's a 6 and a 1 in yellow. So this has to be a 6, 2, 1 triple, making a 9 in the circle. That becomes a 2. The colouring has been incredibly useful here. Now 2 can't be in this region, so that's a 1, 3, 4, which makes up the 8 arrow as we expected. Wow, that's lovely. Now that doesn't work as well up here because we don't have that beautiful arrow giving this grey cell. Actually, there's no point keeping these coloured anymore, I don't think. Let's get rid of the colouring there. Now, this arrow doesn't look as useful because that has to be another low digit, but I mean it could be, it only has to be lower than that. It could be 6, 7 or 8. I don't understand. The 9 and 8 haven't impacted on these things. Ah, this arrow is interesting. These arrow cells can't be 1 or 2 because of that group. So they're at least, they're from 3, it can't be 6 either actually. So they're from 3, 4 or 5, but this is 7, 8 or 9. That gives me a triple, so that's another 3, 4 or 5 there. This region now has 3, 4, 5, 1. This is 2, 6 or 7. Ah, this, actually it could be 2. I was going to say this circle can't be a 2, but actually those could both be 1s, so I'm not going to rule that out yet. Could this be a 1 though? Does there have to be a 1? Oh look, we've got 1s here. Ah, yes, there's no repeated 1 in blue and purple. Look at that, that's lovely. 1 can't be in those cells, 1 can't be in those cells. Obviously these both can't be 1, so only one of them can be 1. But one of them is going to have to be 1 and it's in that group because this lot adds up to 15 or 16. So in fact this is a 2 and there's another 2 down here somewhere. And I don't know which group 1 is in. But 2 is in blue. Oh, this is now a 1, 2, 3, 4, 5 set. And now it does add up to 17 in blue and purple, so that's a 9, 8 pair again. This could be, oh, there's various possibilities. Oh, those can't have 2s in. So there is a 2 down here. Now, that doesn't mean there's a 1 down here. It doesn't have to be. So my 1 there isn't ruled out yet. It will be, don't worry. That can't be a 2 from the column. Oh, and there is another 2 somewhere down here. There has to be a blue 2. I was going to say there has to be a blue 2, 2. Spelled T-W-O, then T-O-O. How do we get a handle on what? Oh, well, this means that there's no 2 anywhere else in the row. And what is happening to 2s in this puzzle? We've got an X-wing of 2s up there. We've got a 2 there. We've got a 2 here. 2 here. There's a 2 down here. Ah, lovely, 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 lovely. That is brilliant. Where does 2 go in this column? That is a fantastic question. It's a fantastic bit of setting to make that question interesting, because you'd never think to ask that. But these tell you that there can't be 2s here and here. That and the fact there's a 2 there means there can't be a 2 in either of those. That can't be a 2 because those 2 can't both be 1, and none of these have a 2 as a possibility. So actually 2 is here. I've just assured you, I think, that we were going to prove this wasn't a 2, and it turns out it is. So that's how much I know. Right, now there's no 1 in this group. It has to be a 2, 3, 4 set, adding up to, oh, it's 2, 3, 4 over here. Nearly put them in the wrong place. Adding up to 9. So that's 9. That's an 8. We can't have 3, 4 in those cells. So yes, 2, 1, 5 does add up to 8. That's a 1 because it sees a 2 and a 5. It's surrounded by a 2, 5 pair. And now we know what all of these colours are. Let's get rid of the colouring. We know what the constituent digits are anyway. Wow, that is so clever. Now, what next? 2, 5. I mean, I could pencil mark everything else, but it seems a bit desperate. Ah. That can't be a 2. Yes, I'm spotting something very nice here. Something perfect. Something perfect. Look, where are 1s in the... Well, there are 1s in all of those 3 areas. This is a 2, 1, 5 group. That's a 1, 3, 4 group. That's a 1, 2, 6 group. That is going to use up all the 1s in columns 7, 8, and 9. So now we know there is no 1 in these cells. They're the ones I'm particularly looking at. Now, is there a 2 in those cells? And there can't be 1 here because of that 2. And we also have an X-wing on 2s in columns 8 and 9. There must be 2s in both of those areas, so there can't be a 2 there. Now, these 2 can't be 1 or 2. The minimum they can be is 3 and 4, and the maximum the circle can be is 7. Isn't that perfect? That's absolutely brilliant. That gives us a 3, 4 pair, so we get a 1, we get a 6. This could actually concertina the whole puzzle considerably. Look, another 3, 4 pair, so that's 2. That's lovely. That's going to sort out the 2, 1 down here. That's going to sort out the 5, 1 up here. Isn't this brilliant? Another 3, 4 pair. I don't think I can use that. What's this now? It's in a box where, or a region where 1, 2, 3, 4, 5 are. Minimum it can be is 6. That's minimum is 3, and that gives you the maximum 9 there. So we're literally away now. This is brilliant. This is the last arrow. Can I do that now? The way this is going, you kind of almost want to bet I can. Now this can't be 1, 7, 3 or 4. So I think 2, 5, 6 are the possibilities. Combo I've seen already. Oh, hang on. That 3 has fixed all of this 4, 3 stuff. So I'm going to do that while I suddenly spot it. There we go. Now this has to therefore be at least 5, and it can't be 5. And actually maybe I can't. No, I'm not quite sure I can do that, but I've got loads in the grid now. So we've got a 7, 8, 9 triple up here, and that one can't be 9. What else have we got? A 7, 8. Oh, 7 or 9 there. 7 or 8 here. 1, 3, 4. What does this column need? 5, 7, and 8. That one can't be an 8. 5, 6, 7, 8, 9. I don't know. Okay, maybe I haven't really thought about these regions in a while. 3, 4, 5, we've got a group there. 2, 1. That's 6 or 7, as it sees 8 and 9. This one could be anything. Oh, okay, I'm getting a bit stuck. Okay, maybe I need to go back to thinking about the low digits. Now we're getting some of them in R. 1 and 2, we've done them in column 5 and 6. So where are 1 and 2 down here? They're not in row 9 or row 8 or row 7 or row 6. Or row 4, or row 1 or row 2. That's it. 1 and 2 have to go in these cells. Fantastic. There we go. So this is not a 2 now. Right, so 5 and 3 is a minimum 8. Ah, okay, don't get that straight away. That's a naked single. It sees 1, 2, 3, 4 there, 9, 6 there, and 7, 8 there. That's a 5. This can't be 5. It's in a region with 5. So now that's a 7, 8, 9 triple. So this is a 3, 4, 6 group. It hasn't resolved that 7, 8 pair. That can't be 1, 2, 4, 3, 9 or 6. So I've got a 5, 7, 8 triple. This is a 3, 4 pair. 3, 4, 2, 8. I don't know what's going on here. That can't be a 9. 1, 9, 2, 8. Oh, I can't do those. Okay, I've got triples here and here. So I'm just wondering, can't I isolate these final 3 columns and work out? I could reduce them to 1 extra region. So there's a 7, 8, 9 here, 2, 5, 1 here, and then 6, 3, 4. I'm just going to colour those. That's 1 region of the digits 1 to 9. Then down here I've got 5, 7, 8, 6, 1, 2, 3, 4, and a 9. So that's 2 regions. So these remaining cells, let's make them yellow to stand out a bit, are another set of 1 to 9. So we've got 1, 2, 3, 4 done. These others are the higher digits. Yeah, okay, that tells me something. It tells me there's an 8 in one of the yellow cells here in column 9. So that can't be an 8 and that can't be an 8. There's also a 6 in one of those two, and I don't know what to do with that information. Doesn't quite make that a 6. Okay, that wasn't all that helpful. I am going to leave the yellow region marked just because it might help me to understand something soon. Okay, so 2, 1, 7, 3, 4. That is 5, 8, or 9, and this is 6, 8, or 9. Now we did the, okay, I focused on 1s and 2s. What about 3s and 4s? Those are a 3, 4 pair. 3, 4s in column 6 have to be in one of those 3 places. I don't think it's as helpful. That's really interesting. I thought it would be. Oh, strange. I'm getting a bit stuck now. That's still not resolved as far as I can see. Twos. Twos are still an X-wing here. Oh, we've got a 3, 4 pair there. 1, 3, 4, 5, 2. So that is 6, 7, or 8. This is 6, 7, or 9. Yeah, I don't quite know now. Let's just keep plugging away, I guess. That is the same one out of 5, 6, 7, or 9 as goes in here somewhere. That's not interesting. 5, 7, 8. Oh, I'm missing some big relationship. Maybe it's this. Oh, this is now... Actually, no, it could be any pair of 3, 4, and 5. Ah, no, it can't be. This can't be a 5. So there is a 5 in these two cells. So this is 8 or 9. That makes a pair with that one. It means 7's in one of those two and not there. That means 7's in one of these two. In fact, that can't be 8 or 9 now because they're in the same region. So 6, 7 pair here. Come on, do something. I'm really getting a bit stuck now. Okay, that 8, 9 pair in the column, that haven't quite got a 2, 3, 4, 5, 6. There must be a 7 in one of those cells. It's not helpful. That's a 7, 8 pair. They're not looking at any one individual cell as far as I can see. That must be the same as that. Actually, in a very similar way, those two are the same. But I don't know what it is. It does mean that these two have different totals. Is that any use? I don't think so. Oh, I'm getting a bit stuck. No, 3, 4 pair there. Now I've seen that before. It didn't do anything. Right, 6, 7, 8, 5 or 9. That's 5, 6, 7 or 8. Just looking at this column, 8, 2, 5, 1, 6. Ah, 2, 3 and 4. Hang on. 2, 3 and 4 in this first column. Look, this is a 5, 7, 8, 9. That can't be 6. This is a 5, 7, 8, 9 quadruple. So 2, 3 and 4 are in these cells at the top. That's a 2. That's helpful. I don't know about 3 and 4, but that being a 2 means that's a 5 and that's a 2. And this has become a 6, and now this arrow is complete. Yes, and that is helpful. 8 there, 8 there. This is now a 3, 5 pair. This becomes a 4. What have we got? Oh, 7 there. That's naked. Yeah, 4 there. 3, 4, 3, 4. Yes, this is all coming now. So I think I just have to let it happen in a way. That's 5, 6, or 8. 6, 7, and 9. Oh, look, this can't be 3. So that's 6, that's 3. This is 7 or 9. Oh, it's a very good puzzle, this. It's really neatly done. I mean, not finished yet, but I'm feeling like I'm getting there now, and those can't have a 6 in. So, what about this 5, 7, 5, 6, 7, 8, 9 quintuple? Don't quite know yet. Oh, yes, I do. There's only one place for 6 in this column. In fact, in that yellow region, there's only one place for 6. So that's there. This column is not being helpful. What about this one? Not entirely, actually. 5, 7, 8, 9 then. Gosh, no, I'm still a bit... I'm sure you'll be able to see something that Yeah, 6 in this car. I should maybe have kept focusing on 6s. How many 6s have I got done now? 1, 2, 3, 4, 5, 6, 7. So I need 6 in one of those and a 6 in one of those. Okay, X-wing, can't resolve them. But this can't be a 6. Oh, I bet there's something. Yeah, there's only one place for 9 here, isn't there? It's got to be there. That's actually probably extremely helpful. If that can't be a 7, oh, and it is a 9, that's a 7. That's 5, that's 9, that's 8. First 3 columns are done. This is a 5. That's in our extra region. So this is a 7, that's a 9, that's an 8. So thank you, yellow. You did a good job in the... Thank you, yellow. You did a good job in the end. Right, and then we can go back and finish off 5, 3, 5, 3, 4. That gives us 6, 4, 8, 7, 6, 7. And in the final 3 columns, 7, 8, 9, triple, which becomes 8, 7, 9. And this is 5, 8, 7, I reckon. And that solves toothbrushes, which is an excellent irregular puzzle. Very good example of the genre. Lovely 2 arrow there. I mean, actually, there were so many really nice bits. These 5 cell regions were very cleverly done, and that's a very clever puzzle. Thanks for watching, as always, on the channel. Delighted to get through another one. Hope to see you again soon. Bye for now.